Standard 3.2 is the setting up of the problem, making sure that we're applying definitions and theorems in the process of solving a problem. So we're setting things up in the right way. So again, we're going to set up all of these equations, and you'll notice the directions are telling you not to solve anything. For number 1, however, we're going to start just by listing the ratios for each trigonometric function. From the figure below, write as simplified fractions. So for the top row, we're finding the sine, cosine, and tangent of angle C. So if I start with angle C, remember, the hypotenuse won't change regardless of which angle we're looking from. So the hypotenuse is always opposite the right angle. Here's our hypotenuse. And then from angle C, we've got opposite and adjacent, the 21 and the 28 respectively. So again, remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So the sine of C is my opposite 21 over the hypotenuse 35, both of which are divisible by 7, leaves me with 3/5. Cosine of angle C, adjacent over hypotenuse, is 28 over 35. Again, the adjacent divided by the hypotenuse, 28 and 35, both divisible by 7, is 4/5. And then finally, the tangent of angle C, opposite 21 over adjacent 28, divide both of those numbers by 7, leaves me with 3/4. Now, the last row has us finding the, I needed the eraser, the sine, cosine, and tangent of angle A. I'm going to leave the hypotenuse the same, but I'm going to come over here to angle A now and switch that opposite and adjacent side. The opposite is now the 28, the side length 28, and the adjacent side is the side that with the length 21. So for the sine of angle A, again, opposite over hypotenuse is 28 over 35. Notice it's the same as cosine of angle C, reduces to 4/5. Cosine of angle A, adjacent over hypotenuse, 21 over 35. The same as the sine of angle C, which is reduced to 3/5. And then finally, the tangent of angle A is opposite 28 over adjacent 21, which is the reciprocal of the tangent of angle C, which reduces to 4/3. Now, for numbers 12 through 17, we are going to set up a trigonometric equation in order to solve for x. So we're just going to set up the equation is all. So for number 12, we'll label our hypotenuse, our opposite side, and our adjacent. We'll notice that opposite and adjacent are labeled. Opposite and adjacent come from the tangent function. Tangent of x, it's the trig function of your angle, equals your fraction, 16 over 12. Again, we're not solving, we're just setting up the equation. So when we grade your 3.2 standard, we're looking to see that you've set up the correct equation to begin the problem. For all of these, we're going to follow that same process. We're going to label the triangle hypotenuse, opposite, and adjacent, and then decide which trig function to use based on our labeled information. So we've got an opposite and a hypotenuse, that's our sine function of the angle, which was 61 degrees, equals x over 22. Number 14, hypotenuse, opposite, and adjacent. Given information is the hypotenuse, and the adjacent, which is our cosine function. Trig function of the angle, in this case 42, equals our fraction. Make sure you get it in the right order. Adjacent over hypotenuse is x over 25. Let's finish up. Now for 15, all three sides are labeled. So we could actually solve this using any trig function we like. Let's go ahead and label that triangle, hypotenuse, opposite, adjacent. If we decide to use the sine function, we would have the sine of x equals opposite over hypotenuse, 7 over 25. We could use the cosine function, cosine of our angle, which is the x, the variable, the unknown, adjacent 24 over hypotenuse 25. Or we could decide to use our tangent. Remember, tangent of x equals, and then opposite 7 over adjacent 24. If we were to solve all three of these equations, we would come up with the same degree measure for our angle. For number 16, we do only have two sides labeled, so this will be only one option for which trig function to use. There's our hypotenuse, our opposite, and our adjacent. We will use our sine function this time. Sine is opposite over hypotenuse. The sine of our angle, remember trig function of an angle, equals the fraction 9 over x. And then finally for number 17, again, hypotenuse, opposite, and adjacent. In this case, we've got opposite, adjacent, tells me to use tangent. Trig function of an angle, this time 64 degrees, equals, our fraction is 36 over x, opposite over adjacent. I'm sorry, yes, opposite over adjacent. Now for 18, we've got a picture happening here, and we're going to do the same thing, just now it's a word problem to go along with it. An observer is standing on the top of a vertical cliff, spots a house in the adjacent valley at an angle of depression of 12 degrees. Notice they placed that 12 degrees, right? The angle of depression was here outside the triangle, but we want to include it inside the triangle right there. The cliff is 60 meters tall. How far is the house from the base of the cliff? So we're going to label this just like we do all the other triangles. The fact that it's a word problem and that there's like a picture and stuff to go along with it doesn't change anything. We still want to figure out what was our given information. We've got an opposite and an adjacent. So we'll set up our trig function using tangent. Tangent of 12 degrees equals opposite was 60 over adjacent was x. And that's how we would solve for that variable. We'll do the same thing here for number 19. From a point on the ground 47 feet from the base of from the foot of a tree, the angle of elevation to the top of the tree is 35 degrees. Find the height of the tree to the nearest foot. Let's do some labeling here. Hypotenuse, opposite, and adjacent. So again, we're going to use tangent. We've got an opposite and an adjacent. So tangent of 35 degrees equals opposite x over adjacent 47. This time we're solving for the height of the tree.